Okay, so today we're looking at how to solve multi-step equations with variables on both sides. So the goal of today's lesson is that you can solve multi-step linear equations with variables on both sides, including the distributive property. So we will have distribution, we will have combining like terms, we will move the variable to one side, add, subtract the variable term, multiply or divide by the variable. So one thing that you'll notice is I'll have multiple pen colors so that way we can follow along with that. So first, let's look at the difference between problem number one and problem number two. So problem number one, variables are on one side. I have 4x here, I have 8x here. Here's my line, that barrier, and here I have no x values. Here I have variables on both sides. I have a 5x over here, I have a 3x over here. So let's go through the steps so in that way we can learn that we can solve using every single one of these steps. So here, my first step is always distribute. Do I have parentheses? No, I do not have parentheses. I'm going to write the acronym right here. I'm going to use these letters D, C, M, A, M. Distributes my first move. There is no parentheses. That step is done. Step number two, combine like terms. So here I'm looking to add two variables together, but all on one side of the equation. So I have negative 4x here, I have 8x here. And I should specify combining like terms can also be constant values, so just numbers. I'm looking to consolidate each side. I have negative 4x here, I have 8x here. If I have 8 of something and I take 4 away, I'm left with 4x. Nothing happens to the 6, so it stays as plus 6. Nothing happens with the 16, so it stays as negative 16. That step is done. Step number 3, move the variable to one side. So if I have two variables, if I have them on both sides, I want to move them, and I always want to move the smaller variable. Here, I only have the 4x on this side, so there is no action here. So that step is done. Now, this is like a normal two-step problem. I add or subtract to isolate the variable term. Here's my variable. I want to get it by itself. Here I'm adding 6, so I need to do the opposite. The opposite of adding 6 is subtracting 6. Nothing happens to the 4x, so I'm going to keep that as orange because nothing happens to it. Positive 6 minus 6 is 0. It goes away, which is what I want. I want that 0 pair. Negative 16 minus 6, if I dug a 16-foot hole and I dig 6 more feet, that's negative 22 feet down. My last step is to multiply or divide because I want to reduce to 1. So I divide by 4 on both sides. X equals 22 divided by 22 divided by 4 is negative 6.5. So the big thing here is when I have variables on one side, I need to combine like terms. And then it becomes the same thing over here. We add and subtract to isolate the variable, we multiply and divide in order to reduce it to 1. Here I have variables on both sides. So to solve my equation, the first step, I should have gone ahead and done check marks there. My first step is to distribute. Do I have parentheses? I do not have any parentheses, so my distributing is done. This, I combine like terms. Is there anything, this is all done on one side. I am not moving anything on either side of the equation. There is nothing to combine over here. I have a 5x minus 4. I can't combine those. I have a 3x plus 10. I can't combine those. So combining like terms, that's done. Now I move the variables to one side. I have variables on both sides. I have a 5x over here. I have a 3x over here. I always want to move the smaller value. When I move this 3x, it becomes a negative 3x. 5x minus 3x is 2x. Nothing happens with this negative 4. Nothing happens with this 10. So when I move it, I am subtracting 3x from both sides, and it's another zero pair. And now, again, I'm back to my two-step problem. I add 4 to both sides. That's a zero pair. It goes away. I'm left with 2x equals 10 plus 4 is 14. My last step is to divide by 2, and x equals 7. And if I plug this in, 5 times 7 minus 4, 5 times 7 is 35, minus 4, that's 31. Over here, if I did 3 times 7 plus 10, 3 times 7 is 21, plus 10 is 31. Those are equal to each other, so that works. So that means out of all of the real numbers, 7 is the only one that can work to make sure that they stay balanced. So let's go ahead and practice here. This is supposed to be 8m minus 5m minus 7. And this is also 3d minus 2. So again, the acronym I'm going to write is DCMAM. So don't call me after midnight. So my first step is to distribute. I'm going to work on problem number 3. There are no parentheses, so my distributing is done. Step number 2 is combining like terms. Here I have an 8 and 5m. 8m minus 5m is 3m. Nothing happens with that negative 7, so I'm just going to bring it down. Nothing happens with this 3, so I'm just going to bring it down. So I have combined like terms. That step is done. Now I'm going to move the smaller variable. I only have the variable on this side. I do not have a variable on this side. So that step is done. So I may not have to do all of these steps, but I do want to check and make sure that they are done along the way. This is my process to solve this. My last 2 steps, I add and subtract to isolate the variable term, and I multiply and divide to reduce to 1. So now, moving the smallest variable, that third step, is the first time I'm looking to move stuff across the equal sign. Here, I'm going to go ahead and move stuff. Instead of subtracting 3, I'm going to add 3. Instead of subtracting 7, I'm going to add 7. This zeroes out. I'm left with 3m equals 7 plus 3 is 10. That step is done. My final step is divide by 3. And I'm going to leave that as 10 over 3. I don't need to reduce that down. 10 over 3 is going to be a decimal that goes on forever, and I do not want to deal with that. Problem number 4. Problem number 4, you start with distributing. I have parentheses, so I want to distribute it away. This becomes 3d. 3 times negative 2 is negative 6. There is no distributing here, so this is negative 6 plus 4d. That step is done. Next, I combine like terms. 3d minus 6, I cannot combine those. Negative 6 plus 4d, I cannot combine those. That step is done. Now I move the smallest variable. I have 3D over here. I have 4D over here. So I'm going to move this one. Instead of it being positive 3D, it now becomes negative 3D. I am subtracting 3D from both sides. This goes away, which leaves me with negative 6 equals negative 6. 4D minus 3D is 1D. So that move is done. Now I add 6 to both sides to add and subtract to isolate my variable. Negative 6 plus 6 is 0. That's 0. And I'm left with equal to D. There is no division or multiplication because there's already one D. So my solution is D equals 0. Which again means that if I plug this in, 3 parentheses 0 minus 2, 0 minus 2 is negative 2. 3 times negative 2, that's negative 6. On this side, negative 6 plus 4 times 0. 4 times 0 is 0, and I'm left with negative 6. Negative 6 equals negative 6, so therefore, out of all of the numbers in the real number system, 0 is the only one that will make this work and make them equal to each other. If I pick a different number, it's not going to equal to each other. Problem number 5 and problem number 6 is when you're supposed to be working with a partner. These two problems, you should end up at the same solution. So go ahead and pick whichever one you want to do. Your solution should be x equals negative 20. And this is your notes for solving multi-step solving equations with variables on both sides using the distributive property. Pay attention, there are lines on the back. That's where you fold. And make sure they get glued and put in your journal.